Hey everybody, so today I'm going to show you really quickly, I'm just going to give you a high overview of this script, but definitely feel free to download this script and use it however way you like. Also, you can watch this video. Just check out the description below where you can find a OneDrive link to be able to download the video and script. I'm using one package, but this package is easily avoidable. I'll zoom into the node and show you. All I'm doing is using the zip function, and I'm just zipping together the start point and end point. The zip allows it to just keep the order of the list. So like these two lists here are the, and I'll show you real quick. So it's both these two list zeros are brought together in this list, and then we have the essentially what would be list one kind of paired up together. So that keeps everything nice and orderly, and then we flatten that list, then we get some points and stuff, and this is just to create the surface, the levels for each level. So to give you some background, the reason why I built this script is because a project team was working on a model where they had multiple buildings on the site, and they were using scope boxes and levels to kind of to manage those buildings. But the problem is the levels weren't constrained to the buildings, so it was confusing when you were looking at it, what was what, and folks are putting things on the wrong levels, and there wasn't filters set up to quickly see that. So it evolved into something a lot bigger. Now, we didn't use a script. Luckily, it wasn't a super big deal to be able to go back in and fix this stuff. We created some filters, but it made me think, okay, maybe we could use a Dynamo script to automate that process. So this is a script to try to tackle that problem. So it'll go automatically figure out, hey, this chair is above level 2 building B, but it's showing level 1 for building A. So something isn't right, and it's going to change it to building B, level 2. So that's the gist of kind of what this script does. Right now it's just focused on looking at furniture, and that's over here. So we're looking at furniture, and that's primarily what we're dealing with, but this script can be customized to have all those different things added to it. The only difference is depending on how those items host to the level, and if they have offsets and different things that could change. If the parameters names are different, there could be some issues. So that's why I don't have all the items. I'm just looking at furniture for now, but you could definitely add to this script. So essentially what it does, and again, this is a high overview. If you get into this script and you have troubles getting it to work, let me know. But I definitely recommend actually opening it and looking at the way that things flow. It's just a nice way to learn. And obviously, if this benefits your project, definitely use it. Pretty much what we're doing here is we're going to check the intersection of the line. So we draw a line from the furniture. So you can see out here there's lines. So it starts off first drawing a line below. So it goes in the negative below itself by 15 feet. If it doesn't clash with anything, then what it does is it loops up here and it clashes against stuff above 15, or it goes above itself. Now, if it does clash something below, then what it does is it filters out what has been clashed with one level. So you can see over here, in this case, these three items way over here have only clashed with one level. So what it does is it'll say, okay, it clashed with one level. So this is what we're going to do with that data. We're going to cross-check the level that item is hosted to and the level it clashed against. If they match, we'll leave it alone. If it doesn't match, then we'll name it, or we'll rehost it to the one that it clashed, which I'll show you that example when we run the script. And then what it does for the items that it clashes to below is it creates another line, but that is 10 feet shorter, to see if it reduces those total levels. If it does, then it takes that one, cross compares to the host level of the element to the one level that clashed against. If different, it updates that parameter. And it does the exact same thing for levels above. Only after it's verified that there's no levels below does it go and actually check above to see if there's any levels above it. And then again, when it gets down to just one level, it takes that one level, cross-checks it to the host level, to the host of that element, and then if it's different, it'll update that parameter to match. So anyways, that's a high-level view. I'm going to show you some visuals of that actually happening. In this case, I also go in and update the elevation, which in this example, I've got two sets of families. One, and all of its furniture, but some of the furniture was created a little bit further back, so it didn't have the offset parameter. And we'll get an error for that. But for items that do have that offset parameter, it will be set to 0. Now, obviously, depending on if it goes negative or positive, you could do some math to figure out just to keep the same distance from it. But anyways, this is just a simple look at just setting everything to 0. All right, so I'm gonna bring this. Oh, and I tried to add a whole bunch of notes to this and groups, so that you could see kind of what was going on from group to group, and you could read it and see what was happening. So definitely check that out, and definitely let me know if you have any questions or any problems. So, anyways, this is the. I'm going to bring over Revit. All right, so this is Revit. You can see over here we have a building A, so it's set to level 01A, and we've got two desks here that are set to the correct level. We have one desk over here that's set to level B. And you can see this one has no offset parameter. Now we have a whole bunch of things over here. So we've got a desk here. One of the things it does do is it says, okay, nothing's below it. There's no level below it. All right, we're going to check above. Well, if it is above and still doesn't find something, then it exceeds 15 feet. Then at that point, it just says, hey, this element is out of bounds. It's too far off. And it's probably intentionally somebody did that, or the item just got flown off, which in that case it filters that out, and then you can still be able to find that element pretty quickly and figure out why that was the case. And that's so, and I'm highlighting this element because that's what's going to happen to this element. It will not update because it will be out of bounds. So this one is for level 01A, and you can see it's offsetted -3 feet. What it needs to do is actually go to it needs to be reassociated with level 00B. And that's the same thing goes for this one. The difference between these two options and why I have these here is because this one above will clash into two things above itself, and that's when it filters out, makes a shorter line, sees if it's still clashing against two. If not, cross-checks this compared to this one and then updates it. For this one, it only clashes against one, so it will cross-check it and then update it. This one's level 01B. which is correct, so it shouldn't do nothing with that one. This one is level 01A with a 10-foot offset, so this one should stay exactly where it's at, except for be reassociated with level B01 or level 01B, and then the elevation set to 0. This should be untouched, and this one, and the reason why I have this one is because when it cross-checks it, it'll leave it alone. So this script isn't necessarily there to update the elevation from level parameter. What it's there for is to see if items are not hosted to the correct level. So it's going to leave this one alone, and because it is associated to the correct level, and it won't. So in that case, it won't pass it on to be written to, or to have the host or the level parameter updated, which that then passes on to the other set parameter node, which is the one that sets the elevation. It doesn't get to that point because when it cross-checks the level that it clashes, it matches with the host level. So anyways, I'm going to run this. I'm going to bring Dynamo up and kind of put it on the side. And then I want you to kind of see what happens to all of these. So you can see this shifts down. The filter shows that it's not red anymore, and you can see it's associated with the correct level. This one, you can see, doesn't do anything because that item is out of bounds. This one, you can see it checked above, and let me rotate that. You can see it checked, the chair was here, it checked all the way up here, clashed against 2 levels, so it made another point, except for, in this case, it went 10 feet, so it said, okay, items, or it made a new line 10 feet, clashed. It said, okay, it only clashed with 1 level. Let's cross-check it with the chair, and the chair did not match, so it updated the chair to reflect the correct level, which you can see now is level 00B. Same thing happened with this one, except for this one, when it initially drew that first line, or the second line, because the first line it checks below. If nothing's there, it draws the second line. And that second line did not clash with any, it only clashed with 1 level. So it just cross-checked that level with the chair, and then it didn't match, so it updated it to match that level, which is level 00B. Also, you'll see when you actually open up this script, and I'll zoom in when I bring back over the Dynamo script, that I use dictionaries quite a bit. Dictionaries are incredibly powerful because what it allowed me to do was be able to read in the level name over here, and then that level name was the key parameter, or it was the key in my dictionary, and then my values were the actual level elements, which I used when I set the parameter for those furniture, or for the different elements. Because though this is just text, the actual way that you can have to write to this parameter is with the level element. So I use dictionaries quite a bit. And just in general, dictionaries are really awesome, and I definitely recommend taking a little bit of time to learn them because they will help you a lot in a lot of your scripts. So definitely check those out. And you can see over here, this one, it's been updated as well to level 01B. I think originally it was set to A, level A. Actually, let's push everything back. Oh, okay, so that one was left alone. And you can see here too, and this is kind of interesting. So this one was left alone. So it says level 01B. But you can see here, it drew the 15-foot line, but then it went and drew the 5-foot line. And real quick, I want to point out, I draw 15 feet down and then I check only 5 feet below, just to filter out that second level so I can get one level. If it does still find that 5 feet below that it's clashing against multiple levels, then in that case, I have it kind of push out saying that, hey, this is too dense. There's too many levels. We can't figure out which one's what, so we're just going to leave that element alone. And that's what happens. But I want to point out real quick that the reason why the second line, when it checks to see that it tries to filter out the two levels into one, that second line, when it's going down, is only 5 feet, but the second line for when it's going up is 10 feet. You can change those around. These were just numbers I put in for this example, but you can change all those values around to make the script more effective. There's still, I would say, a lot of conditionals that still need to happen before this script is really like effective, but I think it's in a good direction and can work really well for at least furniture stuff. But real quick, one more thing is that the reason why it's still checking is because it checked 2, and that's just one step. If it identifies that there's 2 levels, it'll draw that second line that's shorter to try to filter out the levels that are further away. And then it says, okay, if it does only clash against one single level, it's going to cross-check that level against the item's host level, and if it doesn't match, it updates. In this case, it did match, so it left it alone. But anyways, I hope that kind of gives you a good overview of this script and how you would use it. I think it's pretty powerful and could be powerful. But if anything, if you don't see a practical use, definitely just take it and see how it flows. I mean, use it as a learning opportunity or whatever. Real quick, this is the dictionary here. So this is where I actually create the dictionary. Sorry, that is right here. I have 2 dictionaries, but the primary dictionary I use is this one. Okay. Sorry, this one's a dictionary, but I don't use that often. It's this one here that I use quite a bit, and you can see it kind of going off to 4 different things. And the 4 different things it's going off to is and if we just zoom over to one of them, you can see it's going all the way over here, and I'm using it to figure out the levels, to return the levels so that I can tie it into this element set parameter by name. But if we pan back, you can see what that dictionary is. So I'm grouping together the levels and the scope boxes. I'm using that to kind of group things together. And that's the group by function. But over here, you can see what the items are. So these are my keys. So all the levels are my keys. And then my values are the actual level elements. And the reason why I did that is because the elements, so if we pan over here, you can see like the element name. For scope boxes, it returns like level 01A. And if we look at the actual furniture elements, when we return that value, it returns a value that matches this. So level 01A is just a string value. And so this allows us to quickly filter out and grab those levels. I'm going to correct myself really quickly. When you return if you do a get parameter by name node to the family, and it says and you return the level parameter, it does actually return the level. I'm using this because it's easier to manage and it matches the scope box level names, and I'm just using it to quickly manage that stuff and be able to filter in and out, and only really passing through this information into the actual set parameter name. but I'm using like to filter and do all that, I'm using this value here, the level 01A and so on. So the level names, not the actual element. But you can get the actual level element from the get parameter by name, and if you pass that through a family. So anyways, that's what I got. Hopefully you got something from this. If not, well, definitely check out the script and feel free to just play around with that, and definitely feel free to download the video if you'd rather watch it on there. But anyways, or I mean, if you'd rather watch it locally, definitely download it if you want. But anyways, that's what I got. Hopefully, I'll see you in the next video.